Okay, I think we'll get started as people are joining. So hello and welcome to today's webinar titled What's New in the AWS Analytics Stack for 2022. My name's Alexandra and I'll be your MC for the next hour, and thank you so much for joining the conversation. So before we get started, let's cover off some of the webinar functionalities. During the webinar, everyone's microphone will be muted, but we want this to be an open discussion. So if you have any questions at all, please enter them in the Q&A box or the chat window at the bottom of your screen. There'll be a dedicated question and answer session after the presentation. Today's webinar is being recorded and a copy will be sent out to all the registrants at the end of the week. So today's speaker is Miles Brown. He's a senior cloud and DevOps advisor for ExitCertified. Miles has over 20 years of experience in the IT industry across a variety of platforms. He's recognized as an AWS Authorized Instructor Champion and a Google Cloud Platform Professional Architect and Instructor. Miles has delivered award-winning authorized IT training for the biggest cloud providers. So you might ask yourself, why choose ExitCertified for your AWS training? Professionals like you have been training with us since 2021. You want to know your training provider has the credibility to earn your organization's trust, and ExitCertified delivers. Our vendor-approved IT training is our only business. When you train in our facilities, you'll find well-equipped classrooms and friendly staff who are dedicated to making your learning experience comfortable and productive. And when you train remotely with our IMVP virtual platform, you'll see that our investment in technology makes online learning every bit as engaging as the training you'd take in person. So if you have any questions about why you should take AWS training with ExitCertified or which course is right for you, you can contact us just after this presentation or ask us any questions. So let's get started today. I'll hand it over to you, Miles.
Thanks, Alex. All right, well, welcome everybody. As Alex mentioned, my name is Miles. I've been teaching AWS classes, official AWS classes since 2014. That's when ExitCertified got the AWS partnership. Before that, I had a varied IT background, mostly coming from the data side. You know, I started my job as a programmer, really became more of a database programmer, did a lot of Oracle work, wrote some books, ended up teaching some classes for Oracle. And then when Hadoop came along, I became more of a Hadoop guy and did a lot with Cloudera's distribution, ended up teaching some classes for Cloudera. You know, and so that's sort of how my trajectory has gone. And every year I do this sort of same kind of presentation near the beginning of the year, kind of wrapping up, hey, what's everything that happened last year in the AWS Analytics stack? And the Analytics stack has grown over those 8 years. And we're going to look at a lot of stuff. I'll start with a quick, overview of what's the stack look like and what's the big direction that kind of everybody is going as far as this idea of a lakehouse architecture. And then we'll jump right into, hey, what's new in each of these, individual services. And Alex mentioned we'll have plenty of time for questions at the very end. Along the way, I might see some questions as things are happening. I'm kind of looking at the chat, and I may be able to answer some of the questions if they seem pertinent along the way. So let's jump right into an overview of the AWS Analytics stack. If you look at sort of what traditionally people did with the AWS services insofar as analytics goes, you might start with saying, hey, people started collecting a lot of files, log files, all kinds of files, dropping them into S3, and then periodically running some Hadoop jobs on those. And so the main service that AWS has for running Hadoop is Amazon EMR, right? It makes it really easy to launch a huge cluster of servers, install whatever Hadoop, whether it's Spark or Presto or Hive or, whatever Hadoop ecosystem projects you like. And mostly we're doing this sort of, maybe nightly, maybe every few hours, running batch jobs was sort of initially what people were doing. And then, you would output the well-structured, processed files again into S3, and then you could load them into Redshift if you wanted the power of data warehouse. So that we'd have SQL access to that data and, very fast kind of querying on this, purpose-built infrastructure for the kinds of queries we do in data warehouse. And then you could attach kind of any BI tool that you like, whether it's Tableau or Cognos or, you name it. But AWS eventually threw their hat in the ring and said, hey, we'll build a business intelligence tool. And that's what QuickSight is. QuickSight, it's not super popular. One of the things that happens with AWS is when they put out a new product, it's really a minimum viable product. And so a lot of people looked at QuickSight when it first came out and said, it doesn't have all the bells and whistles that I'm used to, right? It looks a little bit like Tableau, but it doesn't have all the stuff Tableau has. But if you look back every year, they add more and add more. And they talk to people who use it and say, hey, what are your top priorities? What features do you want to see? And they add them in there. And so it's getting better and better. And there's something underlying in the Spice engine, which is very attractive. Now, how do we get the data into S3? You can always, there's lots of ways to write data to S3, but typically we're going to use some sort of, way to get data in a streaming format, maybe with Kinesis, or, if you've already got an infrastructure where you're using something like Apache Kafka, well, now we have MSK, the managed streaming for Kafka, which just makes it easy to kind of port those workloads into AWS. Then we have, traditional kind of queuing, whether it's SQS, which is, actually the very first AWS service back in 2004. It's been around for a long time. A lot of people, similar to the Kafka thing, said, hey, I've been using Apache ActiveMQ, in my on-prem. I don't want to, when I move to the cloud, have to manage that myself. Can you manage it for me? And so in the early days, Amazon said, well, you could go and switch to SQS, in which case you'd probably have to rewrite a lot of your applications that were using, ActiveMQ specific APIs. Well, now we have Amazon MQ. And so that lets me talk to things like ActiveMQ or RabbitMQ. And so we got lots of ways to get messaging of data into S3. The other big change over the years was to say, well, what about these two uses of EMR? One use of EMR was here with the ETL, where we bring up a cluster, do a batch job periodically, right? And the other was, well, is there not a way where I could query the data directly on S3? And so it was really Netflix that popularized this idea that said, hey, maybe as we started to see these SQL on Hadoop options get better and better, Facebook came out with something called Presto, which really made querying in a Hadoop cluster on, well-structured data in S3 really easy. They said, well, in the end, what Netflix said was, we're going to cut out Redshift and we're just going to use two different kinds of EMR clusters. One that does periodic batch jobs, right? Bring up, a cluster, run a Spark job, and then it goes away. And that would do my ETL. And then the other one, instead of using Redshift, we would have a cluster just for Presto so that we could do SQL querying on this well-structured S3 data. And that was their data warehouse. Well, Amazon looked at that and eventually said, hey, maybe we should help you with this. Maybe not everybody has to be an expert in Hadoop and building and running clusters. Even though EMR does help us a lot with that, there's still a lot of decisions. How many nodes? What kinds of nodes? And instead of doing that myself, maybe I can just borrow a cluster that Amazon has and just pay per use. And that's really where Amazon Athena came in. Athena is a SQL on S3, was originally where it started, right? And so I could use Athena instead of running my own EMR cluster with Presto, because that's really what it was under the covers. It allowed me to do S3 querying. And so that might be a replacement for my data warehouse. I just have well-structured files in S3, right? I could also use Athena to go and query the raw data, right? And so that's one way Athena changed things. Similarly, what about this EMR cluster doing the ETL? Well, that's where Glue came in, right? And Glue was this sort of serverless ETL engine where, again, there is a Hadoop cluster running. It's just not one that I'm managing, right? And they have all kinds of tools to make certain kinds of jobs really easy where maybe I don't have to code at all, right? I can use a lot of the sort of predefined kind of transformations, and I can avoid writing code. Or they'll show me the code, and if I know Python and Spark, well, then I can go and tweak that, or Scala, I guess, either one. But and that was sort of a big question. Now, Mohammed asked the question, when do I use EMR versus when to use Glue? That's a great question, right? If you already have expertise in Hadoop and you know how to manage a Hadoop cluster and you built specific Spark jobs and they're all there already built and you're just moving into the cloud, well, then EMR makes a lot of sense. But for my money, if I'm starting from scratch in AWS, I'm probably going to use Glue, right? Because it's less code for me to write. It's easier to manage. I don't think about the cluster ever, right? And the way you pay for it is I'm paying for, how long this job runs, basically, rather than, how many nodes times how many hours, the economics of it are a little different. So this is sort of where things got to probably about 4 or 5 years ago. Things started to look like this, right? Probably about 4 years ago when Glue and Athena really started to become popular. And what we realized is not everybody needs a traditional data warehouse, right? And these well-structured files on S3, we can query the heck out of those. And we also still keep our raw data in S3. And that sort of grew this idea of a data lake, right? Where we have a central place where we store all our data. And S3 is a perfect place for that because it's not going to lose the data. It's very durable. It's very cheap storage, and it can store files of almost any kind. And if they are well structured, we can use Athena to query them. Later, they added sort of like Athena into Redshift, and we have something called Redshift Spectrum, which allows us to run queries in Redshift that query the data in Redshift, but also point to external tables in S3. And so that sort of started an interesting idea where they said, I kind of like one interface, whether the data is in the data lake or maybe in Redshift or maybe in some other purpose-built database, right? And AWS is not alone in this. This is a big shift in analytics across the industry. At ExitCertified, we teach not just AWS classes, we teach all the cloud classes, right? Google Cloud, Microsoft Azure, but we are also partnered with a bunch of other vendors like Cloudera and Databricks. And I don't teach the Databricks classes, but I talk a lot to my colleague who does. And I have to keep abreast in it because I do a lot of work with our salespeople, trying to help people get into the right classes and everything. So I'm really up to date on what's in those classes. And what I found is that they're really pushing this concept of a lakehouse architecture. And so all these vendors are starting to look that way. And this is sort of AWS's take on it. I grabbed this visual from a blog article from last year where they really started to push it, where, the lakehouse architecture here, I wrote this, acknowledges the idea of taking a one-size-fits-all approach to analytics eventually leads to compromises, right? So it's about integrating that raw data or the data in its natural state, in our data lake, sitting in S3, with the data in the data warehouse and also in other stores like, whatever RDS databases we have or DynamoDB or, whatever it is. And adding all to that, the governance of, hey, where did the data come from? Who's allowed to access it? You need some governance around it. It's really easy for a data lake to become a data swamp, right? If you get unregulated data, nobody knows who can do what with it. And so eventually AWS kind of built this reference architecture for their lake house. And so, the storage layer is largely S3 and Redshift, right? And there's now nice native integration between it because I can run Redshift queries that access the data in S3 tables, and actually vice versa. When I come in through Athena, I can query both of these as well. Now, how do we get the data in there? There's lots of different ways. Kinesis for streaming data. We can use the data migration service to do sort of change data capture on traditional databases and get that data in there. data sync to grab files from file servers, maybe on premises or wherever. Even AWS AppFlow was kind of cool for grabbing data from certain SaaS applications, things like Salesforce and stuff like that. It's a nice visual editor to grab my data out of there and get it into, say, S3. Now, the S3 might be broken up into a bunch of different layers, right? We could have the landing zone where we drop all the data. The problem with just dropping raw data is it's not in a really good format for querying immediately, right? Because a lot of times you have just raw log files and they're not well structured. You have to kind of massage the data to make it nicely usable. But every time you alter that data, you're losing some context. You might be losing data. In the old days, with that ETL process where we take all the data from our transactional databases, we would aggregate it, clean it up, and then load it into a data warehouse. There's a lot of bloodshed, right? We left a lot of data on the floor. Well, now we say, no, we're going to keep everything. So we'll keep all the raw data, but then we'll go through a series of cleaning it up, processing it, getting it into better formats. So we have a trusted zone and then a curated zone. There's different levels to that. And in order to sort of deal with setting this thing up, and more importantly, the governance on, hey, I want this user to be able to access this table in S3. Well, how? Through Athena, through Redshift Spectrum, through Hive or something EMR, right? Spark. Well, how do I make this table available to all of them? I have to have a data catalog. And then I've got permissions like, hey, on the Hive table, I'm allowed to query it, but do I have access to the data in S3, right? And so it becomes a real pain. And that's where lake formation came in, right? Lake formation is the way to easily, and quickly set up this data lake, but also set up the governance around, hey, you're allowed access to these tables. And I make one sort of, role-based access there. Then we've got all our ways to access the data, either through EMR or Glue to put the data in or massage the data in there, Kinesis and Spark streaming and all those options, and Redshift Spectrum, and then Athena to query it. QuickSight can connect to all these different things to query. And even SageMaker, if you're doing a lot of machine learning, can access the data. And so that's sort of the idea that AWS has. Now we're going to come back and see, a lot of the new features that came in 2021, in each of these services was to really make that integration with lake formation, to make make things harmonious, to make this lake house really a possibility. So we'll start with the streaming side of things. We're going to look at some new features in Kinesis. Then we'll talk about the managed streams for Kafka and a little bit about Lambda, just because we need a little bit of Lambda to make it all work. So Kinesis, it holds streaming data collected from various data sources. And the big idea, it's like Kafka. You set up this stream, it holds data for a period of time, and then one or more consumers come and grab it on their own timeline, right? So I might have, log data coming in. I might have thousands of IoT sensors firing every 100 milliseconds, sending me little bits of data. And all this data comes in, and what are we going to do? We're going to hold on to it for maybe 24 hours, or you can change the period. But then I have different consumers that are interested in these little events, right? Some of them might be interested in saying, hey, every 100 milliseconds, I got to grab that data and do some machine learning, right? Or it might be, hey, every 5 minutes, I'm collecting data and updating some dashboard. Another one might be saying, hey, every 10 hours, I'm just grabbing all the data, deduplicating it, and storing it in S3. And so that's the big idea of Kinesis. And there's actually 3 main services. There's actually video streams as well, but we're not going to get too much into that. But the 2 main services these days are Data Firehose and the original Kinesis data streams. So Firehose makes it really simple to say, hey, I've got little bits of data coming in really, really fast, right? Could be hundreds of thousands, could be millions of writes per second, right? Usually too much to write to most things like a Redshift database or even an S3 bucket, right? So what are we going to do? We're going to aggregate the data and then periodically write it out to S3. Or if you're going to go to Redshift, what usually, in the past, it's always used S3 as an intermediary. You would write it out to S3, and then you would copy that data into Redshift. But eventually they added a bunch of other targets for things like Splunk and other like third-party kind of places. So that's Firehose. And the big idea there is it's really simple because I don't have to think about partitioning. I don't have to think about writing the code that's the consumer to grab the data and aggregate it or anything. It's more of like configuration. You say, hey, grab this data, and whenever we get 5 meg of data, or every 60 seconds, whichever happens first, batch it up and write it. Kinesis data streams is just a much more generic kind of, hey, I write the consumer as well as the producer that puts the data in. And so I use APIs to go and build those consumers, and I can have multiple consumers, but I'm also on the hook for managing them and making sure that, if they die, then their replacement comes up. So that's your more sort of, you get more control, but there's more work to do. And then one thing they added a little after that was Kinesis Analytics. They said, whichever of these streams you have, instead of writing more code for if I need another consumer, I could, if the data is well structured, I could take that existing stream of data and kind of run SQL queries on it. If I could figure out how to layer, create table, if it's tab delimited, comma delimited data, whatever, maybe JSON data, I could create a create table command, and then I could use SQL and now Apache Flink processing of the data in that stream instead of having to write another consumer and find somewhere to host it, right? So that's sort of what Kinesis looks like. Now, the biggest new thing I would say is in Kinesis data streams, they've added this sort of on-demand for auto-scaling. Because one of the big pains of managing Kinesis data streams is when you create a stream, you have to tell it how many shards make up that stream. And each shard can take about 1,000 writes per second, and about 1 meg of data per second. So you have to kind of look and say, okay, I need 300,000 writes per second, so I need 300 shards. And what if that changes over time? I've got to merge or split shards. It's a real pain to kind of manage that if things are dynamic, right? And so Kinesis data streams on demand lets us just sort of not worry about that, right? So that's kind of a big new thing, right? Another big one is, and when I use Firehose to aggregate data and throw it into S3, I used to just throw it into one S3 bucket. All the data that we were collecting goes into one big bucket. Of course, if we're going to try and do any kind of querying on that data in S3, it's better if our big bucket is subdivided into, partitioning, right? So you might have, okay, here's the sales for January, February, March. And so those are subfolders of the folder where we put the data. And there was never any facility for that. So you'd always have to okay, just throw it into one bucket. Then we would build a little simple EMR job or glue job that would take the data and basically partition it and put it into another S3 bucket for me. Now, we don't have to do that extra job. We have dynamic partitioning for Firehose delivered S3. And so you tell it, okay, use these prefixes, and then this kind of data goes here, this kind of data goes there. And the last big new one here in Kinesis is the addition of Kinesis Analytics Data Studio. And it basically provides, like a notebook, based on, I think it's based on, this one might be based on Zeppelin or Jupyter. I can't remember which one. But it's for doing ad hoc querying of data through Flink, right there in a nice sort of, interactive way. And so that's sort of, they've got notebooks all over the place. We're going to talk a lot about notebooks here, but one here in Kinesis Analytics especially. We used to just have a little box where in the management console, you would, play with the SQL a little bit. But when you got into Flink, all of a sudden you need more of a notebook environment to write scripts. And so this provides that. So that's a few things new in Kinesis. What about this MSK? Right, so that's the managed streaming for Kafka. They make it really easy to port existing Kafka apps into the cloud by providing managed service. In the old days, you had two choices if you wanted to run Kafka in AWS. You would either just launch a bunch of EC2 instances and have to manage it all yourself, or you would say, no, instead of Kafka, I'm going to switch to Kinesis, but I might have to rewrite all my apps. Right? And so this provided us that nice, easy way. Now, MSK was introduced way back in 2019, but a lot of updates arrived in 2021. Important ones, right? It used to be that you would have to have some sort of little access management system for Kafka just to keep track of users and who's allowed to do what. Well, they introduced AWS IAM access control this past year. Right? They also introduced MSK Connect. So if you know Kafka well, you know that there's sort of Kafka streaming, and then there's Kafka Connect for building the connectors to get your data in and out of your Kafka stream. And so MSK Connect is a nice serverless Kafka Connect cluster to ingest the data in there. Right? Another thing they did was they allowed us to secure connections to MSK over the internet through either AWS IAM, SASL Scram, or mutual transport layer security. So they just beefed up the options and now makes it a little easier. And then I guess the last one, which is still in preview, is MSK serverless. So you don't even have to think about the cluster capacity. You know, the big idea of this as a managed service is I don't have to manage the individual machines on which they're installing Kafka, you know, dealing with the operating system and updating Linux and all that stuff. But you still have to think about how many nodes do I need? And what if my data needs change? I got to change those. Well, MSK serverless just says, hey, don't even, you know, worry your pretty little head about it. We'll take care of how many nodes are there, when to grow, when to shrink, all that stuff. So that's still in preview, but you should be able to join that preview. This just came out, I think, probably this was announced in November at reInvent, or maybe December. So that's MSK. A few things in Lambda, not a lot here, but I'm sure everybody taking this probably knows a little bit about AWS Lambda. It's basically this concept of serverless compute, right? So I write a function and then I configure what's the trigger that causes that function to fire. And it could be something like, oh, somebody uploaded a file to S3. That's an event, go run this code. And then you pay for how long the code runs. And you don't think about the servers on which it runs. You're not paying by the hour for them. You're not managing them, fixing them. You don't think about high availability. Where is this going to run? I just trust that AWS will find somewhere to run it. Right? So, you know, things like uploading a file to S3 or stream events, like a new message comes into Kinesis. Right? I could say, hey, every 100 events in Kinesis, go run this code. Right? Same thing with, you know, changes in a DynamoDB table, those go into a DynamoDB stream, and we can do that. So they've added some new event sources for Lambda functions. So MSK, so that Kafka kind of thing. Also for Kafka that you're managing yourself on EC2 instances. And they also use that mutual transport layer security. Amazon MQ. So when a message comes into an active MQ or RabbitMQ, you know, you can use that. And they also added the ability to have your Lambda function run in a different account than the queue where a message comes in. Mm-hmm. So that's some new event sources that came in 2021. Another thing they did was they said, it's kind of expensive to fire the Lambda function on every message that comes in to, say, an SQS queue. When I'm only interested, this Lambda function only has to fire if the messages look like something. Right? So that concept of event filtering, they've added it for SQS, Kinesis, and DynamoDB. And the big idea there is, you know, I can put like a little check that happens at the queue level that say, hey, is this the kind of event that I'm interested in? Yes. Okay, then call Lambda. Right? Another thing that they added in, which sort of helps out a little bit for SQS, is partial batch response. So if you have, you're saying, hey, go grab 10 messages from the queue and run this Lambda function, right? It'll run it 10 times on that data. Well, what happens if one of them fails? Some of them were, you know, in the old days, we would just roll everything back and you'd have to grab all that data again. Right now we can say, hey, these ones worked and these ones didn't. So we can kind of deal with partial batch responses. All right. So that's what's new in Lambda. When it comes to storage, we'll just talk a little bit about S3. S3 obviously is the cornerstone for most people's, big data plans in AWS. In 2020, S3 added support for multiple destinations when you do replication. We used to have cross-region replication where you said, hey, everything I write to this S3 bucket, I want you to also copy over there. And it was mostly used for disaster recovery. Something really bad happens, this region goes down, all that data is over there in another region. I can bring up my infrastructure there and get going. Well, people started to find that the latency of reading data around the world is a bit of a pain. So it might actually be beneficial to have multiple copies of the data and people work on it wherever they are, right? So that's something that came in 2020. In 2021, they added the idea of S3 multi-region access points. So these use, under the covers, AWS Global Accelerator, which basically considers factors like network congestion, the location of the requesting app. And so basically it says, hey, when I want to read this data from S3, I go through an access point. It's got an access point in each region where the data lives, and it'll grab it from whichever one is fastest, whatever that means, right? And it's also not going across the internet, it's going through the AWS global backbone wherever possible. So you can really accelerate your performance by up to 60% when accessing those data sets that are replicated around. Okay. Some other new features in S3, support for event bridge notifications. So like, say you wanted to do something, hey, when a new file comes in to S3, that's an event. I want to go and build an application that deals with that, right? Well, what if I wanted to build multiple applications that react to that same change? And what if I wanted to replay last events? Well, we'd end up having to keep track of those events and additional copies of the data. Now we can use Event Bridge. And so when that event occurs, that goes into an event bridge and we can have multiple people dealing with it. And we can, kind of look back at past events and replay them. The biggest change though in S3 is that they changed some of the object storage classes. They changed a couple of the names, they added some new options. So the best way to look at this is to just, go and look in the, it's not even in the documentation, it's basically in the main S3 web page, they talk about it. And so now we've got S3 standard, that's your kind of basic, hey, I want to put data, I want to access it fairly frequently. Then you've got infrequent access, standard IA, right? And standard IA says, I'm not going to access it very often, so I want to pay less for storage, right? You take that to its next logical conclusion and you get Glacier. Well, Glacier, they've renamed to Glacier Flexible Retrieval and Glacier Instant Retrieval. So there's a little bit of a difference between them. So instant retrieval is an archive storage class that delivers the lowest cost storage, but we can still access the data in milliseconds. Okay? So you can save up to 68% on storage costs, but your data is still accessible. But, you're going to pay every time you access it. So, there's a trade-off there. If you're accessing it all the time, don't use Glacier. For that matter, don't use standard IA, right? And then you've got more, the flexible retrieval, for data that's accessed maybe 1 to 2 times per year. And it doesn't have to be right away accessed, 3 to 5 hours or whatever. Then you've got deep archive where you really get into the, hey, I don't need this data really, right? I've done all the analytics I need to on it. I would throw it away, except, disk is cheap, right? Deep archive, super cheap. So why would I throw it away? Especially when, I might have some sort of compliance that says you've got to hold on to this data for 5 years or 7 years or whatever, right? And so what do? We compress the heck out of it. We put it into the deep archive and we say, there, it's the cheapest it's going to be for storage. But if I ever need access to it, it might take 12 hours to get the data back. You're like, oh, we're getting audited. We have to be able to access that data to show that we still have it, right? But the auditors can wait 12 hours. Never like those guys anyway, right? So that's the idea. And so just a few name changes there. And then the intelligent tiering, they've tweaked a little bit as well. Intelligent tiering says, well, what if you don't know your access patterns very well? You're going to grab some data and you might use it very often, you might not. And then over time, you probably use it less, but you're not sure, is it 2 weeks? Is it 6 months? When does it all of a sudden not get used? So when you're unsure, that's when you use intelligent tiering, because it'll store it and it'll look at it and it'll say, hey, you haven't used this data for a while, so let's move it to infrequent access. And it can even move it into some of our archiving options. So it goes between frequent, infrequent, and archive instant access. And so it can save you a lot of money, especially, but the best way to do it is if you know exactly the usage patterns, then set it up and set up a lifecycle policy that says it's in standard for 2 weeks, then it goes to infrequent access for the next 6 months, then it goes into Glacier Deep Archive. Like if you know the exact access patterns, that's your best way to save money. But if you're not sure, then intelligent tiering is a good way to start, right? And so, just a few name changes and that's the big idea there. All right, well, let's get into the bulk of what we're going to talk about here, which is, EMR, lake formation, Athena, and Glue, and then we'll end with a little section on Redshift. So EMR, we talked about, is a managed service for running Hadoop. It now supports the S3 access points to simplify access control, right? So if you are setting up a data lake in S3, you could create hundreds of S3 access points on that shared data lake, right? Each corresponding to some department within your organization that has specific access permissions. Then when you're building jobs for that, you can use a specific department's S3 access point and it'll access only their data to process it. So that's kind of an interesting idea. The other big thing that they announced in preview is support for EMR serverless. You're starting to see a trend here, right? Things that were managed services that you still had to think a lot about capacity and growing and shrinking them, they want to take that over. And so EMR serverless will automatically determine and provision compute and memory resources and scale them up or down. So that's still in preview. Okay? The other big thing that they changed in EMR is EMR Studio, right? It finally became generally available and they added lots of features, right? And so it's basically a fully managed Jupyter notebook with tools like Spark, UI, and Yarn Timeline Service, and all kinds of like PySpark and everything in there. It supports now multiple languages in the same notebook, right? That's a new feature. You can execute external Python files and external notebooks. And so this introduced sort of real-time collaborative notebooks. Right? They beefed up support for access management. So initially, when it first came out, EMR Studio could only use AWS single sign-on. Now it can use IAM, it can use IAM Federation. They've gone through and they've made sure it's HIPAA eligible and high trust, which is sort of, it kind of started in the healthcare community. It's not restricted to just that, but it sort of amalgamates and says, well, we're worried about HIPAA compliance, we're worried about PCI compliance, we're worried about GDPR, all that stuff. And so, being high trust certified means I can run in that kind of an environment if I need to. And the other thing they added in EMR Studio was beyond just using, Python and Scala and stuff like that, they added a new SQL Explorer. So we can run sort of like Presto queries on your EMR cluster. The other changes they made in EMR are really to help us with our lakehouse architecture. They really integrated nicely with Apache Ranger. If you're not familiar with Apache Ranger, it's all about fine-grained access control. And there was a way to make that work in EMR before, there was a blog article and people kind of looked at that and tried to incorporate it. Now it's officially supported. And so I can do database, table, and column level authorization policies. And then whether you're using Spark or Hive, to access through that Hive metastore. And we can also do prefix and object level authorization policies when accessing data in S3. and even use CloudWatch to capture audit logs on that. Right? So that was sort of a big move. They incorporated that. Then, kind of on the heels of that, they added support for Spark SQL to update even the Hive metadata tables when using the EMR integration with Ranger. And I guess building on top of that, then they added support for Spark SQL to update, the AWS Glue data catalog when using the lake formation. So that's sort of all built one on top of the other. That was a big thing. But the newest thing that they added just in this last reInvent was support for Apache Iceberg, which is sort of an open table format for large data sets, like S3, and it provides fast query performance over large tables, atomic commits, concurrent writes, SQL compatible data table evolution. So this idea that we want our S3 to not just be append only. Right? That's how most people think of S3. I put files into S3. I don't edit them, right? I'll do some sort of an EMR job, take these files, massage them, and write out new files, right? But this is saying, no, the data in S3, we can make changes to it. We can do, atomic commits, right? So building on all this, if we go and look at lake formation, which is that sort of managed service that lets us build and secure our S3 data lake, they added something called governed tables in S3 to simplify building, data pipelines with multi-table transaction support. And it supports row and cell level permissions. And once you've set it up, a table in lake formation on top of S3, I can query it through Athena or Redshift Spectrum or Glue or QuickSight. Then they also added managed VPC endpoints to access data lake in a VPC and use your regular kind of VPC security controls to decide who can get where. They added support for tag-based access control. So I can use tags on databases, tables, and columns, and then decide who can access them that way. So that's the big changes there. And we're getting very close to talking about Athena, I think. Oh, we're here. Okay. So Athena, we talked about briefly at the top of the hour. Athena is a serverless option to do querying in S3 using ANSI standard SQL, right? That came out a few years ago now. Then they added in federation. So I don't have to just query S3, right? It can query data in Redshift, in Amazon Aurora, in other RDS, anything with a JDBC driver, we can now set up so that we can run these queries. Right? Some new things they added this past year, parameterized queries, like most traditional relational databases. When I run a query, if I run the exact same query a little bit later, and I say, hey, go query blah, 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 where customer equals 101, and then I do the same query where customer equals 102, we shouldn't have to do all the same work in building the execution plan and everything again, right? So using parameterized queries improves reusability and security, it turns out. Cross-account federated query. So my Athena doesn't have to be necessarily, I can access data in somebody else's account. Presumably they've given me some permission somehow, right? But yeah, we can do that. They introduce user-defined functions. You have to write them in Java. They have a nice API for building them. It now presents a query plan. So you can look at an execution plan and see, how can I tune this query better? It was always just sort of a black box. It went and ran the query, and then you paid for how long that query took, right? So this helps, certainly. And they now built in support for cross-account Glue data catalogs. So I can make my Glue data catalog that says, okay, I've got this table in this AWS account and this table in this account. This one's in S3, this one's in Redshift, this one's in, an RDS database. And now our Athena can talk to that catalog and grab data from all those different places. Now, that's probably something I should have added into the next slide for new in Athena for the lakehouse architecture, right? Because that sort of helps with that ability to use one place to grab all the data. But they've expanded their Apache Hudi support to simplify incremental data processing in S3 data lakes. They just added some more support to Athena. The Apache Hudi's been supported for a while in EMR. This just sort of makes it available through Athena. Added support for the new lake formation, fine-grained security and reliable table features that we talked about earlier. And in preview right now, they have ACID transactions with Iceberg. So this is sort of the way things go. They introduce something in EMR, and then they eventually make it available in Athena for, on those EMR clusters, they expose it. So it's still in preview, that part. Now, if you want ACID transactions, it is already supported through governed tables, but this is a newer way of doing it that might be a little easier for people. All right, so that's Athena. The other sort of managed Hadoop cluster under the covers for us was Glue, right? It's serverless ETL. I don't have to think and provision about running an EMR cluster. It can crawl all kinds of data sources. That's the big thing with Glue, right? There's sort of three elements to it. There's the crawlers that will go and look at your data sources, figure out what the schemas look like, and update the second part, which is the Glue data catalog. And so that catalog is really under the covers. It's a Hive meta table, meta store. But then I can use that when I run queries in Athena or EMR or Redshift Spectrum, right? So it ends up being the main Glue. That Glue data catalog is what we use as our metadata storage for everything. So that's been around for a while. And then the last part, which is the actual ETL engine. Right? So many new features in 2021, especially for the two main UI products. And so this is another one of those, Mohammed asked, what about EMR versus Glue? Here's another one of the, when do I use Glue Studio versus Glue Data Brew, right? And maybe this will help. We say that Glue Studio is a visual tool for writing and monitoring ETL jobs. So it's really, you got to think jobs. It's all job focused. So I'm building ETL jobs. I'm running them, and then I'm in a single pane of glass. I want to look at all my jobs and monitor how they ran. Glue Data Brew is for a slightly different audience, and instead of thinking about jobs, you're thinking about data. So it's a visual tool for data preparation and data profiling. So it's really targeting more the data scientist who says, I'm not building these pipelines and products. I'm an experimental person. I've got data in all these different data sources. It's a real pain for me to grab it from all those places, clean it up. Here in this table, it's called F name. In this table, it's called first name. In this table, the, phone numbers are in this format. In this table, they're in a different format, right? I got to clean it all up and all that kind of thing. And I'd like to do it with as little code as possible because I don't want to spend my time writing all that code. Well, that's where Data Brew really comes in. Right? It's about taking the data, cleaning it all up as much as you can. They've got all kinds of built-in transformations, and then they can profile that data, and then I'll use it in SageMaker or wherever my tools are for machine learning, probably. So let's look first at Glue Studio. You can now read uncatalogued data from S3 and infer its schema. So you don't have to go just through data catalogs. But that's mostly what we'll be doing. We've already crawled the data, and we've got it in the Glue catalogs. Well, one of the new things they added was the jobs can actually update the Glue catalog. So previously, if you were looking, if you needed to write to a pre-existing table, right? So when I wanted to output, I'd say, oh, I have to have that S3 location, write data to it, and then I'd have to run a crawler on it at the end of my job to make that available in the catalog. Well, now I can actually have the job create that data and update the data catalog for me all in sort of one pass. Glue Studio now includes a code editor for customizing your Spark scripts. You used to have to download the script and edit it somewhere and then upload it back. They now have a nice little code editor right there. Another thing that they've added is this idea of data previews. While you're authoring your job, you can kind of say, hey, show me what the data might look like at this level, at this step. And so they take a subset of the data and walk it through. And this idea of writing Spark scripts, I mean, that's the big thing with Glue, right, was that under the covers, they're going to be using Spark, and they build these Spark jobs, and they'll write a lot of the code for you, and they'll say, here's the part that you can edit, right? But it really required you to be, a Python or Scala developer who knew Spark. Right? Well, now they have new transforms that are just defined using SQL. Right? So you don't have to be a heavy duty developer to use it necessarily. Right? So there's built-in transforms, but the ones that are not available as visual transforms, I might be able to use SQL to do some of that processing. So that's some of the new things in Glue Studio. If we look on the other side, Glue Data Brew, they added a lot of advanced data types and delimiters for transformations. So, whether it's a social security number, email addresses, phone numbers, credit card numbers, they know how to take that data and say, okay, well, it did just look like a string. Now I'm telling you it's this, right? Let's see what else. So a lot of new transformations for basic number formats, phone number formats, data masking for personally identifiable information. There's some cool stuff there. They have transforms for custom sort and multi-column sort, logical operators, so I can have multiple transforms and use ands and ors and nots, nesting of things, unnesting of things, handling outlier data, so they've added a lot of features to Glue Data Brew. We'll take a quick look in a second. They've also added the ability to specify which data quality statistics you want generated as they're doing their job, their transformations. And it now supports writing the prepared data to a bunch of different destinations. It used to be just like, okay, put it to S3 or put it to Redshift. Now we can put it into any JDBC database. It can write to Tableau hyperformat, Glue data catalog tables. We can write to catalog tables, things like that. Glue Data Brew is now HIPAA eligible, just pretty handy if you're in that healthcare. So that's some new features in those GUI tools, but what about just general Glue features? Well, those Glue crawlers, we used to have to kick off a Glue crawler, the crawler that would go and look at my data sources. You could do it ad hoc whenever you wanted, or you could set up a schedule. Well, now we can do it based on an S3 event. When some new file comes in, we can kick off a crawler to say, hey, somebody dropped a new file into an S3 bucket. I don't know what that is. Let's go figure out what the schema is and build a table for it. Mm-hmm. I mean, assuming it's well structured, we'll figure it out. Mm-hmm. They have event-driven workflows with Glue and EventBridge. So I can kick off my Glue job based on whatever event you want in EventBridge. To make life easy for people starting out, they built Glue custom blueprints. So you can parameterize and reuse some workflows. So they have some there, and then you can build your own blueprints. They've added some machine learning at various points to do some things. One of the things they added was this idea of imputing missing values. So we can look at your data set and say, you're missing some values based on some machine learning. I'll figure out what we think those are. Right? So that's pretty cool. I think that's the main new features. Yeah. And then there's a few features that are still in preview. So four new features that are in preview, like they just announced them at reInvent, and usually takes till April, May, June before some of those things that were announced become real. So they have this idea of interactive sessions, so you can process data interactively in a notebook or an IDE of your choice. Features fast startup. And then if you don't have a notebook of your choice, you can actually use the Glue Studio job notebook. And so that'll let you save and schedule your notebook code as a Glue job. So you sort of, you used to have to build it somewhere and then go and build it up as a Glue job. Now it's sort of the place where you're building it becomes, oh, here, that's the job run. That's the promise of notebooks, right? This idea of PII detection and remediation. Well, we saw that, It's again doing some pattern matching, some machine learning at the column and cell level while it's doing the glue job and saying, hey, this looks like a social security number. We should probably obfuscate this somehow, you know. And then we saw that gets picked up in glue data brewer as well. And I guess the last one in preview is Glue 3.0 can now dynamically scale resources up and down based on the workload, both for batch and streaming jobs. So that's the, again, the dynamically scaling is you're not paying for X amount of servers under the covers for the duration of the job. There might be different steps in the job that need more or less processing. And so it'll scale them and really helps with cost savings. All right, last little bit is on Redshift and QuickSight. I'm going to go pretty quickly through it. The Redshift architecture that we had for many years, starting from 2013 on, was you had a leader node and a number of compute nodes. And when you set up a cluster, you told them how many compute nodes and what kind to use, right? And they stored the data in local disk on those compute nodes. And so the leaders node's job was the SQL endpoint. So you send your query there. It builds an execution plan, looks at the, are you allowed to do this query? And then it would basically build an execution plan, compile some code, and send it to the compute nodes. So they weren't very smart. They just did their work. Right? Well, eventually they decided to separate the compute and the data. Right? In 2019, Redshift introduced a new type of node, the RA3 nodes. And they basically said, what if the storage on the compute nodes wasn't the actual storage, but we used it for the caching of the data that's accessing all the time? And we actually store on some underlying Redshift managed storage based around S3. Right? And so we could get these very large high-performance SSDs that are local caches. The data is persistently stored and scaled separately in a managed storage layer. So by separating the compute and the data, we can have a lot of storage really cheap and maybe a smaller cluster because we don't need as much compute, or vice versa. Right? So data is automatically moved between the local SSD cache and the managed storage. Based on machine learning algorithms that decide, hey, which data blocks are in use a lot, right? And you pay the same low price regardless of where the data lives, right? And so that sort of opened up everything that they're doing in the future with Redshift, right? So separating that thing really helped. And really what they want to do is less at the compute cluster. And so Aqua, they introduced probably a year and a half ago, but it took till sometime last summer, or I guess in April, it started to become GA in some regions where they're pushing more and more down to this Aqua layer. And what you get, you don't really care, but it's 10 times performance due to offloading a lot of operations down to where the data lives. Right? So over the last year, Redshift added a lot of sort of self-management improvements. So the automatic table optimization that used to figure out your sort keys and distribution keys for you now can do column compression as well. The automatic workload management that usually keeps track of how many queues and how much memory to allocate to them can do concurrency scaling. So adding more cluster. Some other new Redshift stuff, support for native JSON, pretty cool. Hierarchical data queries. Finally, Redshift ML is generally available. I'm not going to get too much into that. That's a whole can of worms. Data sharing across clusters, they can do it in the same account, in different accounts, in different regions. So this idea that your Redshift data isn't stuck right there. Right? And they've added RSQL. So you used to have to use like a third-party tool if you wanted a command line access to your Redshift data. Right? And so you just use the Postgres one. They now have one that supports all the features. Right? And then we used to be able to do federated querying. So inside a Redshift cluster, I could run queries that talk to, say, a Postgres. Now it supports MySQL and Aurora MySQL. A couple of preview things. Materialized views came out in early 2020. They now have this idea of automated materialized views, where they look at queries that happen again and again, like maybe repeatable workloads like dashboards, and it uses some machine learning and says, would we be better off to make a materialized view and refresh it periodically? and we'll maybe do that under the covers for you. Lots of improvements to the Redshift query editor, including a query SQL notebook kind of preview. More notebooks, right? Streaming ingestion support for Kinesis data streams. So instead of having to have Kinesis write to S3 and then load it, they do it all at once. So that's all in preview. QuickSight is our BI tool. The biggest thing that they've generally is GA is QuickSight Q, where you have a dashboard somebody builds for you. You can write natural language queries in there. What is our year-over-year growth rate? And it can kind of figure it out for you. They also have this data set as a source where you can, a curator can create special central data sets that they grab data from different places and make that available to authors. And they have threshold alerts, so you could pick any KPI in a dashboard and make an alert and say, hey, when this goes over a certain threshold, let me know. And Spice now has incremental refresh using a timestamp column. So instead of having to refresh all your data in that Spice layer, you could, tell it to incrementally refresh certain data. And the last thing, versioning in data sets. All right, well, we're at the top of the hour. Basically, if you want to know more about analytics on AWS, the big data blog is a good place to start. But we have 3 classes that kind of fit, AWS authorized classes. The big data on AWS class talks a lot about EMR, Kinesis, Athena and Glue, things like that. The planning and designing databases is really just covers your basic RDS and NoSQL options. And data warehousing is a 3-day deep dive into Redshift. And I think Alex just threw those in the chat if you want to grab those. Hopefully you can save the chat. I'm not sure. It depends on how you're running Zoom, but you might be able to, in the chat, hit the ... and you might see a save chat. And then you can get all those links. Otherwise, you might want to take a minute now to grab those links. Otherwise, I'm open for questions. I didn't see too many questions along the way. It was a real fast marathon there at the end, trying to get in within that hour. So I'll be here for a couple more minutes if you have questions. I'm also going to put my email address. If you have questions after, this is a good place to send them. You'll also see that in these slides. I think you're going to get the recording of this presentation sent to you. I don't know, Alex, when is that? Maybe later in the week or?
Yeah, by the end of the week, we'll send it out.
Okay. Did you see any other questions that popped up along the way?
No.
Yeah, nobody used the QA.
No.
Mostly people use the chat, I think. Well, like I said, it's a lot of data thrown at you at once. I just wanted to kind of let you know that, every year they're adding more and more, right? There's a lot to it. And you might not be interested in all of it, but maybe something hits where you're like, hey, we could use that, right? And it saves you from watching 40 hours of reInvent presentations, which is what I have to do. Hopefully that saves you some of that time. Oh, yeah. Is there an AWS path for certifications you guys have in ExitCertified? What's the URL for that? Yeah, sure. Let me just show you. Bring up my browser here and just go to ExitCertified. So if you go to AWS, you'll see all of our training classes, but under certifications, this is where you'll see our certification paths. Somewhere in here, certification roadmap. Now, this isn't the one where I get an actual URL for it. Where's the one that's got a URL?
I'd like the URL to this page here so that they can
yeah, maybe I'll just throw that in. Yeah. So,
I just threw it in the chat.
There, you put it in.
Yep.
Okay, yeah. Okay. Yeah, so this one's got a little pop-up if you click on the certification roadmap, but you'll see if we scroll down, it's usually on the second page where you'll find the analytics stuff. Typically, if you're coming in no knowledge of AWS, we like everybody to take the one-day tech essentials. But if you've been using AWS for a while, you can certainly skip that. And most people will take either the 3-day architecting or sysops to get the basics of AWS before they go on to the big data class. And the big data class will mostly prepare you for the data analytics specialty. Now, I say mostly because you're going to have to do some study, right? I always tell people, hey, we're teaching a class Monday to Wednesday. Don't run out and write your exam on Thursday. And there's a lot to it. But a nice follow-on after that is the one-day building data lakes on AWS class. If you're more interested in the data warehousing, we've got that 3-day data warehousing class. It doesn't have as much of a prereq, 1-day tech essentials is enough to get you ready for that. Here's the machine learning path. The 4-day machine learning pipeline is the best way to prepare for the machine learning specialty. And then there is a database specialty. We've got that 3-day planning and designing databases, which again, it's an advanced class. They expect you to know AWS. So you take either the architect or the sysops first. And then, there's all kinds of other paths here. So you can find that document on the link that Alex put in. Again, you just find it under it's kind of funny. It's a white button on a white background, but where it says certification roadmap. But that's in the certifications tab. If you look at the training courses tab and say you are interested in something like the big data class, which is probably the most relevant one here. If you look at the big data class, you click on it, you view the schedule, and here's March 22nd, April 5th, May 3rd. It runs at least once a month, probably every May 3rd, May 17th. So that class runs fairly often. The building data lakes is a 1-day class. That doesn't run quite as often, I wouldn't say. Let's see, March 15th, April 18th, May 17th. Looks like every 4 weeks. All right. Well, I don't see any new questions. Well, you've got my email. Hopefully you had time to copy all those links. And thanks for attending. I don't know, Alex, any closing remarks?
Perfect. Thank you everyone for attending. Thank you for the questions. You'll get an email with this recording as well by the end of this week. So thank you so much.